All right, so we're going to examine the conditions for each one of these outputs to be on now, and that's going to answer your teaser question I left in the other video. So obviously we said as soon as we provide system power that PB1 is already going to, so let me use red, I want to use blue. As soon as we provide system power, PB1 is already going to be closed and CR1 is going to automatically energize unless we press that button and open it. So I'm just going to walk down. Now bear in mind that as we're doing each line of this, it may change some conditions, and we'll go back to that. We have to kind of take it line by line, little by little, because it is logic. But obviously for PB2 to energize the coil of CR2, we have to press PB2 and close it, and that will eventually energize CR2 as soon as those electrons, which flow at the speed of light, can get there. Now, we know that both of the relay contacts we see connected to CR3 are normally open contacts. That means we know that either CR1 or CR2's got to be energized. And I said that the right way because we know that our voltage is right here that represents current, and we're trying to get one of these normally open contacts to close. Now, if it's CR2, that means current would flow through CR2 and come over here, contact, and come over here and energize CR3. And if it's CR1, the same thing would happen, and it would go through and energize CR3. This is what we call an OR condition, meaning that either CR1 or CR2 or both could close, causing this to come on. So ultimately, either one or both of these relay coils would have to be energized in order for this to come on. But only one of them would do. It doesn't have to. It only has to be CR1 or CR2 or both. It can be both because obviously both will still provide a path to get us power. All right, so we know that this is a normally closed relay contact, and CR3 can't be on in order for it to be, but we're going to pretend it's not. And so if CR3 coil is not energized, then we're going to get current flow through that, and we're going to light our L1 light. So really what we've got to do is walk up and down this, know the conditions, and apply them to the next rung. But I'm just walking up and down right now and talking about the conditions to turn on the output, not relative to anything that's already happened up here. We're just talking about what has to take place. So we said there was a difference here, and that difference is in order for current to flow, we know this normally open contact has to close, and this normally open contact has to close to get power here. So both of these relay coils would have to energize. So this one and this one. This is what we call an AND logic here. So just one by itself would not power M1, but both of them together, A and B, or 1 and 2, would power it. So that is the AND state of contacts in a row. So this and this has to be true, whereas this or this has to be true. So again, this is just walking down and looking at each output as it exists, not relative to all these different combinations, because obviously we get some different combinations here. But I just wanted you to see how current would have to flow through each rung to get this output on. So that was the answer to your teaser and a little more information on how these work.